Now we're just doing a little unit conversion, okay? Still the heat of fusion of the water, okay? Or rather of the ice, which is still H2O. But instead of joules per gram, which is what I calculated with my 209.2, it's kilojoules per mole. Okay, so just different units, no big deal. I need to convert the joules to kilojoules and the grams to moles. Okay, so grams to moles I can calculate here. I have 2 hydrogen and 1 oxygen. Okay, so there's my molar mass for water, 18.01. That's what I'm going to use to convert here. Okay, so here's joules per gram, and I want kilojoules. Let me go ahead and write this out. Let me put it out in the longhand. Okay. All right. So 209.2 joules per gram. Okay, I'll say per 1 gram. And then I want to multiply this by the molar mass. Okay, which is in grams per 1 mole, right? So now my moles will cancel, rather my grams will cancel, and I'll have joules per mole. Okay, so then I just need to divide this by 1,000, because there's 1,000 joules per kilojoule, and so that would be 0.2092 times 18, and what I would end up with here, if I just take that number, divide by 1,000, multiply it by my 18, here is my kilojoules per mole, the heat of fusion. Okay, so 3.769, or it'd be 3.77 to 3 significant figures. For the percent error, it says to see the lab guide for the equation. In the notes that I sent, I said to use 334 joules per gram as the true value. Okay, so we want to find the percent error. We know the formula for the percent error, which is just the actual minus, or rather it's the experimental minus the actual divided by the actual. Okay, and then of course times 100%. Right? So experimental minus the actual, our experimental value in joules per gram was 209.2. Okay, let me clear out this stuff. Alright, so 209.2 joules per gram is my actual. I'm going to put that in parentheses. There's the actual minus, that's the experimental value that we calculated from our experimental data, minus the actual, which is 334. That's what I said to use. I got that from a reference table. And we divide that by that actual value again, multiply by 100%, and we get negative 37.337 or 37.4 for the percent error. Okay, now we're just going to put this in as a positive number instead of a negative number, because well, even though it's on the low side and so it should be negative, Chem 21 wants it positive. So we're going to put it positive, and it came out with the right answer there. Alright, so here we're moving on to the heat of neutralization part, and it's asking for the mass of the HCl solution, which is just going to be the difference between those two masses. Okay, so here I've calculated that difference, and we get 60.2193 in my case. Okay, what's wrong? Okay, it didn't like that. Why? Okay, I see now that I've calculated the wrong difference. It's actually the difference between these two. So we have 98 minus 36, 62.2787. There we go. All right. And here we're looking at the mass of the neutralized solution. Okay, so the mass of the solution is just the total mass of the original solution as well as the HCl solution. Okay, so if we go back up here, the mass of the original solution, we calculated that. Where is it? Here it is. Number 10, mass of the resulting sodium hydroxide solution, 50.6678. Remember, we put that one aside and we added it to the HCl. Alright, so here we're going to take that mass and add it to the HCl mass, and we get a total mass of 112.9465. Alright. Okay, now we want the change in temperature of the solution. We have the maximum temperature reached was 27.8. We have the initial temperature, and so we just simply subtract those two. Let me move some of this stuff out of the way here. Alright, so here are my temperatures. I subtract them, and I have 6.2 degrees as my temperature change. Okay. The heat in joules gained, so it's going to be positive, by this solution. Okay, so heat, I need Q equals mc delta T. I just calculated the mass of that solution because this is for the solution. After I've combined them both together. And again, we're going to use the specific heat for the water, and the delta T that we just calculated. Okay, so mass of the solution times the specific heat for water times the change in temperature, and that gives me my joules, 2930.